Hi guys, Shouvik here. Welcome back to our channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have count subarrays with fixed bound. So yeah, on that question they have given an integer array nums and two integers min k and max k. Now a fixed bound subarray of nums is a subarray that satisfies the following conditions. What are the conditions? The minimum value of the subarray is equals to min k, and the maximum value of the subarray is equals to max k. So these two conditions should hold. These two conditions should hold, and we have to return the number of fixed bound subarray. But we have to return the number of fixed bound subarray. A subarray is a contiguous part of an array that we all know. So let's suppose they have given to us an array and they have given a min k and max k. Now we have to find how many subarray in which if I am going to search the minimum element, it should be equals to my min k, and if I am going to search the maximum elements of the selected subarray, it should give me max of k. The maximum element should be equals to max of k. So on this example test case, you can see the fixed bound subarray are 1, 3, 5, where minimum is 1, which is equals to our min k, maximum is 5, which is equals to our max k. And in this also you can see the minimum is min k, maximum is max k. On this example you can see you can generate there are 10 subarray which is like fixed bound subarray you can generate on this example. Like everyone is equals to 1, so you can select like four elements, like that is n into n minus 1 by 2. So 4 into n into n plus 1 by 2. So 4 into 5 divided by 2. So 5 4 equals to 20 by 2 equals to 10. So that's the reason it is 10. So as all are equal, so how many ways you can, how many like subarray you can select? It is nothing but n into n plus 1 by 2. All the subarrays is going to be valid here. Yes, I think the problem statement is very clear, and now here you can see like it is kind of like 10 raised to the power 5. So if you write a standard root like generating all the subarray, and you can check like on that subarray what is the subarray, which all the subarrays which is like satisfying the conditions, like minimum is equals to min k, maximum is max k, right? You can do. But on big of, so the root it is going to be take off big of n square kind of time complexity, which is bound to give you a TLE. So I am not going to discuss the like root. I am like directly jumping on the optimal solutions, right? So now let's jump to our OneNote. So I am first trying to give you the intuitions, what actually the coming to your brain when you are basically trying to do something like this. So what actually the conditions should always satisfy, what actually the conditions which should always satisfy. So in the subarray, so let's suppose this is a subarray, this is the subarray A B C D, and what conditions we can say it is a valid, what conditions we can say it is a valid? Its minimum elements, let's suppose its minimum element is nothing but this B, and its maximum elements, let's suppose this D. So all the elements, so now our minimum is equals to our min k, the min k is given, and our maximum is equals to our max k, which is given, and all the elements A, what are all the elements? Rest all A and C. So A and C are bound to lie. Maybe there can be any conditions that can be greater than equals to anything A, between A and C, but they are bound to lie inside min k and max k. So on the problem statements, the array we are considering, all the elements, there can be any array of I in the subarray we are considering should be within the range of min k and max k, are bound to satisfy, and the minimum should be equals to this, and the maximum should be equals to this. So there should be a minimum, the minimum element should equals to min k, and the maximum element should be equals to max k, and there can be many more other elements which is bound to lie these conditions, Now with this, if now let's try to build, if with a forward go, with a forward iterations, can we satisfying these conditions? So again take an array. So let's suppose this is the given array. On the given array, let's suppose the elements are A, B, C, D, E. Now I am giving you a reset case, or where we can say reset case kind of, where we can say that if we encounter this element, we know the subarray we are considering, all the elements should be lie within this. So these conditions is bound to satisfy, So let's suppose there is an element, let's suppose this C, which is not violating this principle. and let's suppose this E, which is also not satisfying this condition. So can I say, like when we encounter such array, so when we encounter any such x should be let's suppose index from 0 to n minus 1, 0 to n minus 1, x can be an index such that nums of x, the value of that particular index is more than, not equals to, is maybe more than of my max k, or this nums of x may be smaller than my mean k. If we altogether encounter such elements, so can I say maybe till now we are trying to build a subarray, this is violating the above, this is like within the allowing the above rules, like within min k and max k. B may be within min k max k, but this C it is violating. So within this C it is violating. So what is the subarray we are considering? We know by considering this, the entire subarray that we still now is kind of good. We still don't know it is good or not. We still don't know it is good or not. But including this is surely not. It is violating this principle. It is following this principle. That means it is violating the bound subarray conditions. Similarly, this elements is another one. This elements is another one which is maybe violating, which is also violating the above principle. So when we encounter such array, what we are considering so far, we can't continue to go. We have to reset what we consider. So maybe on very initials we have start with some variables, but if we encounter such a like bad guys, we have to reset from next. So whenever we encounter such elements which are allowing following this principle, so that means they are bad. So we have to do reset. Whatever the very starting configurations we are carrying, we have to go back to that configurations, and from whenever it is start following these principles it is start following, from there we can again start to calculate. Now let's go with the example. Now let's suppose we have the array. We have the array. So let's suppose this E is an invalid, and from F we have to again start a reset. So this is a blocking element. So now what we can actually do? So when we are standing at a particular, so before going to the optimal solutions, tell me guys, like root is very simple, right? For root you can write two for loops, I and j. I starts from 0 to n, j starts from I plus 1 to n. And when we have a window kind of things or two pointers kind of things, then we should be optimized with two pointer sliding window when we are running two for loops, one starting from 0 to n, another starting from I plus 1 to n. So there is a window we are considering from I to j. So there is obviously a chance to reconcile our answer based on some fact. So first try to go with the forward loops. So on the forward loops, so what we will do? I am on the same go writing the pseudocode, so that like the actual code when we are going to iterate, it is just going to put on your brain, because we are writing the pseudocode on the fly. So let's write the pseudocode on the go. So for I in range n, we are going to iterate on the forward. So let's suppose it is a good element. So if it is a good element, so that means the elements we are considering, nums of I, is following the principles of min k and max k. If it is so, then we are interested on few more things. In which index? So if I say this particular subarray is valid, like considering this R, considering this is my right pointer, considering if I consider this is my right pointer, so now what all the left we can consider? Considering this is my right pointer, what all the left in which it is valid? If we are able to calculate, so then can I say my job is done? What all the else are satisfying the conditions? What all the else are satisfying these conditions if we are able to do so? So what we are looking for? There should be definitely a min k arise, and there should be definitely a max k arise. On the subarray we are considering right as an end. There should be a min k index, there should be a max k index. They are bound to happen. Now can I say what actually the extreme left they have arrived, in which actually the extreme left they have arrived, right. So let's suppose our min k has arrived at this index, so our max k has arrived at this index. So can I say till this it is valid, till this it is valid? No, because on this our min k is not, because our min k is not going to consider, our min k is not going to consider. Can I say till this it is valid, till this it is valid? Can I say till this it is valid? Yes, till this it is valid, till this it is valid, till this it is valid, because here our min k has also arrived and our max k is also arrived, min k is also arrived and max k is also arrived, right? Agree guys, agree, very agree. So out of the min k and max k, now give me one more example. So let's suppose this things is also extended on left also. So let's suppose b also arrived here, c also arrived here, right? Let's suppose they also arrived on these particular positions also. So but do we have to care of that? Do we have to care of that? If they also arise the left, extreme left, then we are good, we can incorporate them. But we are looking from this R, what is the minimum left, what is the minimum window we can consider, considering this right as a right side of the extreme right of my subarray. What is the minimum left? Can I put my left here? 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 What can I put my left here? So what is the conditions? What is the conditions in which we can put our mean L? We can put our mean L. What is the point? We can put our mean L. It is nothing but in which the most recent min k and max k arrives. So most recent min k is arrived at this index, most recent max k has arrived at this index, because we know this two we can consider, this two we can consider, this two we can consider, they all are good. But what is the most small window size? What is the most small window size? What is the formula then? What is the formula then? So our left bound should be minimum of, so let's suppose we have two more variables, min k recent, most recent min k, and max k recent. Like most recent, when we have seen them, so let's suppose this is index, if I can write it in terms of index 0 1 2 3 4 5. So which is the minimum L, considering this right as a valid, this right, this one is the minimum window size. So can I say it is nothing but the minimum of both, minimum of these two, right? Minimum of min k recent and max k recent. The most recent index we have seen them, we can say till them they are valid, So our left bound is nothing but minimum of what are those, min k recent and max k recent, right? Minimum of min k recent and max k recent, right. But before that we have some cases. Let's focus on that cases later, but we have some cases. So can I say considering right at this point, this is the very small left we can put. This is the smallest left to right boundary we can put where the conditions are satisfying. So can I say all of its left are bound to satisfy these conditions? Yes, because all are within the range, because we are considering all the elements within the range, min k and max k, then only we are considering. So now take, if I can again write it here, or let's suppose this index is x, something x, right? And this is a violating index. So we know this minimum, this L2R is valid. Now we have to find how far we can move this L. So this L is the smallest L. Now we have to find how far this L can be moved. Right? So we know this is the invalid index. So just after that all are valid. So maybe we need another variables which is pointing to this index, which is pointing to this left index, So this is actually pointing in which index this conditions is satisfying, in which index the conditions, very first conditions is satisfying. And this left boundary, this extreme left boundary is stating us it is the smallest left to right you can consider. And there could be another variables, there could be another variables, there could be another variables, which is basically stating this is the most left, this is the most left where till where you can expand your left, till where you can expand your left, till where you can expand your left, right. So if we have both, so is it not a straightforward, guys? Is it not a straightforward, guys? Now what we are considering, now we know our left can grow minimum of this, but all of its left till this left boundary are valid, till this left boundary is valid. So this is first valid, second, third. So it is nothing but tell me, guys, answer is nothing but my extreme left boundary, that extreme left boundary minus of left, the left that we are considering, minus of left that we are considering plus 1, and we have to say a max of 0 with it, because there can be this entire things can be negations out, so we should increase our answer, whenever we are in the range of these conditions, so now there are more cases, that's the reasons we have decided to write something here. So we have to update our mean left count, mean left, most recent k, most recent mean k, most recent max k. So our mean k recent is going to be updated to I if nums of I is equals to our mean k, and similarly if our nums of I is equals to our max k, then we also have to update our max k recent with the current index, and also we are carrying with a left which is stating what is the extreme left where after where all the things have started following the rules, or just the right pointer, before that all are invalid. Before that we have encountered some invalid index. What are the invalid index? Invalid index conditions is this. So maybe just after that we have encountered an invalid index. So this left is pointing to that index where it is first valid. Thus current subarray we are considering. So we only have to update if our left is altogether in -1. So that means it has just encountered a bad index, bad elements. So we have to update to our index I. Only that conditions. And so this is this if conditions. And tell me, guys, what are the else? If that is a bad index. For bad index, what we have to do? We have to reset everything. First resets, we will reset our left to -1. So that means we have encountered a bad guy. And our most recent mean k is also going to be set to -1. That also need to be reset. And most recent max k is also going to be reset to -1. Is also going to set to -1. That is the else case. Yes, guys, the problem is as simple as that. So if you are able to understand these steps, and if you are following these steps only, then your job is done. Right. Now let's go to the code iterations. You will definitely get this exact same things that I have explained. I have written on the code. So the code is very simple. So I have started n to be len of nums, and I have started with 3 variables: mean k recent, max k recent, left start, and answer. These 4 variables. And here you can see, so I have written exact modular code. So that exactly you have to write on the interview. So here you can see, so here the actual for loops is going to be executed if this condition is valid. So that means it is lying to the valid range, mean k, max k, nums of I lying on this range. So if it is so, we validate and get mean k recent. We will validate if it is equals to mean k recent. So here in these functions you can see validate and get mean k recent. We are checking if nums of index is equals to mean k, then we are returning the current index. So that is the most recent index where we encountered our mean k, and if it is not, then we are returning what is the mean k recent already there. We are returning mean k recent, and we are resetting our mean k recent. If max k recent, exact same things I have written. If it is equals to max k, then I am returning the index, and I am returning on the else case I am returning max k recent, whatever the value is stored there. And here left start. So our left start, it is validate and get left start. So if our left start is altogether -1, then we are returning the current index, because from this particular index we are starting considering a valid subarray, because just maybe before that, we have just encountered an invalid bad guy. So we are returning current index to be a left stat. And if it is not, then the whatever the left stat we are carrying so far, that only the valid left stat. Now there is a check. If this particular index, if on this particular index we all together have to calculate our answer. So here you can see, is answer calculation required? So see guys, how I have named my function. So exactly that way you have to, in the camel case way, it should be meaningful in the camel case way. On the same template, you have to try to write your code on the interview. Then you create a different bars from the other candidate to get yourself on the selected position. So on the same way, you have to write the code. Try to write the code in the different small functions. I can also write everything on the this logic is like very simple one liner, two liner logic. I can write on the same functions, but if I can write on the same for loop, so the readability of the code is going to be exhausted. So that's the reason. Try to write the code in the small functions with the proper name. So now we will check if answer calculation is required. Tell me guys, what is the conditions we have to consider our answer? So the condition should be, we at least have to encounter our min k and max k recent. So both of them should be present. If both of them should be present, then we should have to calculate our answer. So here you can see a fixed bound subarray of nums is a subarray that satisfies the following conditions. So the minimum value is equals to min k, maximum value is max k. So that means we have to encounter both of our min k and max k. How we can check? So we have passed our min k recent, max k recents, the indexes where they are currently lying. So I am checking if my min k recent and max k recents both are holding some indexes not equals to -1. So that means both are present, and I am returning true. And else case I am returning false. And if it is so, so answer calculations is very simple. Validate extreme left, mean of min k recent, max k recent. We just saw on our OneNote. And what is the left start? What is the left very left start? So valid extreme left is pointing, that is the smallest left to our L2R you can consider. But your L can be grow. Your L can be expand to at max of left start. So how many combinations till here? What is the valid combinations of left pointer then you have encountered? That is nothing but your valid extreme left minus left start plus 1, that we are continuously doing from our last 2 to 3 videos. This formula, very simple mathematics. And if it is not, then we have to reset all of our current carrying useful variables, and finally we are returning our answer. Yes guys, the problem is altogether hard, tagged as a hard difficulty, but I don't think so. Like, it is kind of a medium problem altogether. You just have to play with your 2 pointers or the sliding window you are going to consider, and you are able to build your answer. See guys, like how many lines of code I have written? It is hardly maybe like within 20 lines of code, but the way I have written, so this way you have to follow on your interview. Please try to write your code in the modular way, and with the proper structure of your thought process. Yes guys, so that's all about this particular problem. Now quickly discuss the time complexity. So tell me guys, I think you guys should be till the time complexity on your own. So tell me guys, what we are doing? We are just iterating a single for loop. Are we doing anything? No. We are doing our job in big of in time complexity. Exactly, big of in. We are doing in single for loop only. And on space perspective, are we using any extra space guys? Tell me, are we using any extra space? No. Everything is within the variable. Everything is in variables only. So on space perspective also, it is of constant space. It is a big of. Yes guys, so that's all about the most optimal time and space complexity that I am able to think of this particular question, and I am definitely sure that this is the most optimal time and space complexity for this particular problem. And if you guys are able to understand till this point, so please do subscribe to our channel. I think you guys are already doing, and please share the videos who are actually preparing for top product based company, so that they can also get most of it. And please turn on the notification so that when we are going to live to our next video, you can get the notification as soon as possible. So that's it guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.